Hello class. This week we're going to take a look at some more NumPy, just a little bit, one example that I want to go through that's a little more fun, and then we're going to move into Pandas. And you'll see several examples in Pandas. We will be doing another module utilizing Pandas next week when we do some data analysis. So we'll see some more advanced stuff next week, but we're going to get at least an intro to it this week. So, topic 1. NumPy in 3D. So last week we did NumPy where we could have one-dimensional arrays where it's essentially just like a list or just an array, a plain array. Or we could do multi-dimensional in 2 dimensions where we would have an index 0, which was vertical, and an index 1, or axis 0, which is vertical, and an axis 1 that was horizontal. This time I'm going to show you an example where we do it in 3 dimensions. And I just said all that, of course. I went and looked at a bunch of examples to try to find one that would really demonstrate the value of 3-dimensional NumPy arrays. There are plenty of values to them. However, they are very mathematical and in most cases were pretty dry and not exciting. So I just went off and decided to do something completely different here. I'm doing an impractical example of a 3-dimensional NumPy array. So hold on tight. In this example, we are going to load some ASCII text art into a 3D array, and then we are going to utilize that array to output ASCII art based on a user's input. So here's a picture of the beautiful ASCII art that we're going to load. This is the text file that's here. You can pull this down from Blackboard as well. It's just 8 wide by 8 tall ASCII character art. Not super exciting here, just dots and hashes, but you can see that I've got the letters of the alphabet, and all of them fit within that 8 by 8 spacing that's available. So, now onto some code. This code just barely fits on here, so we should be able to demonstrate it without exiting this view. First, of course, we need to import NumPy, just like we did last week. And then I'm going to create an empty 3-dimensional NumPy array. So you can see I've got my text NumPy, and it's np.empty, which just means it makes it a blank array. And then I have to tell it the dimensions. Now, as I believe I alluded to last time, when you do your dimensions of a 3-dimensional array, axis 0 is what you would consider the depth of the array. Axis 1 would be the height of the array, and axis 2 would be the width of the array. So when I get this all done, I'm going to have a cube, well, I'll have an elongated cube, I forget the terminology for it, but it'll be 26 long, or deep, 8 wide, and 8 high. So that's how I'm defining that, and I'm going to tell it the data type of string, because this is all string stuff I'm doing here, there's no numbers in my array. And then I'm going to have some empty variables that I'm setting up that I need to use to increment as I load my array. So I got those two. And then I'm going to open that text file, and I'm going to load this array 1 character at a time. So first I'm going to open the file. I've got a couple more counters here that I need to start. And then I'm going to say for line in ASCII art. This is just like file loading we've done before. I'm going to grab the first line off of that file, and then I'm going to work with it. I'm going to strip off the end of row character using the rstrip there. And then once I've stripped it, all I've got then that I'm working with is right here, because I'm grabbing the first line in the file. It's those 8 dots in this case. I'm going to grab each dot in the line. So now I've got a for loop inside my for loop. This one is to do each character in the line. I'm going to grab that character, and then I'm going to put it in its perfect positioning in the array. And to do that, I have to use array depth, which again, axis 0 is first. So array depth starts out as 0, which essentially means I'm in the first depth slice of my array. And then I'm going to grab the height, which is the first line in the first depth position in the array. And then I'm going to grab the first position in that first line. So if I was thinking of this in Cartesian coordinates, a 3-dimensional Cartesian coordinate, it would be 0x, 0y, 0z. Like I'm right at the beginning, right at the origin point. And then I'm going to assign it the character that I've got, which is a dot. Okay. Once I've assigned that, then I'm going to increase my character counter because I'm going to want to move to the next character in that row. And then I'm going to check, hey, because I need to always make sure when I get to the end of that first 8x8 block that I go to the next letter. So as long as I haven't gotten to the end of that first 8x8 block, I'm going to increment my line counter. So that's after I've done this for loop and I've grabbed all 8 characters, right? So we've got the first row in the array is ... And then it's completed that because I've run out of characters. Now I'm going to check to make sure I'm not in the 8th row, or essentially would be the 9th row of the file. As long as I'm not in the 9th row, I can increment to the next line. And then I'm going to add a line to letter complete. So if I wasn't in the last line, well, then I'm working on the next line. That's what I'm doing here. And then I'm resetting my character counter to 0, because when I get to the next row, I got to start again. Okay? If all that happens, then we just go to the beginning of the for loop again for grabbing the next line in the ASCII art. If I happen to be at the end of a character, so I've gone 8 rows into that file, I need to start over, but I need to go 1 array depth in to my array. So instead of being in the very front of the array, I'm going to go to the next 8x8 block backwards, essentially, in the array, and do it all over again. So if I get to the end of the first letter, I need to move back 1 position in my array and then do it all again. And you do this over and over and over and over again until you get 26 depth in the array, 1 for each letter in the alphabet. And then your array is loaded. You can see how this could definitely go awry if you get something out of order. So it's really important that you remember that you've got to do axis 0 is depth, axis 1 is height, and axis 2 is width. Then you can always mentally picture where you are working in your array as you go. It also is really important that you use good variable labeling. If I just had counter 1, counter 2, counter 3 or something, I could probably throw myself off here and make this thing not work. So it takes a lot of focus and good labeling and just good thought process as you build these things. So essentially, by the time I get to the end of this for loop for line, I've got my entire array loaded with my ASCII art. And I am going to, what am I doing at the end here? For count in range. I am just printing out one of my characters, I believe is what I'm doing here. Or maybe I'm printing the whole alphabet. Let's find out. I'll have to exit this view to be able to see it. Okay, so I did set this up to print the whole array. So it's printing from range 0 to the size of the array. And then it is going to print out the text, essentially. So you can see I get my first. This is how you see a 3-dimensional array in Jupyter Notebooks. This is the first depth, and then it goes down to the second depth. That's a B. That one's a little harder to see. And then C, D, E, F, G. So obviously you can't see a 3-dimensional array in a 2-dimensional space. So it just goes down on the screen to show you each depth in the array. But the important thing is here I now have it loaded, and I can use it. So I've got it loaded with my awesome ASCII art, and then I can access it based on its position along index 0. So I've got to just throw a number on each one of those letters. So I'm going to do that here with this dictionary index. You can see it's key value A, or key is A, value is 1, key is B, value is 2, through 26 letters in the alphabet. That way I can use I can increment through it or match a letter to a depth in the array, essentially is what I can do here. And then I ask the user to give me a name or whatever you want to input. I take that input and I say for each letter in the input, grab the depth of the array based on the dictionary index. So if I do A, it will become 1. And then I have to subtract 1 because I went and did a 1 instead of 0, because it's always the first position is position 0 in Python, as we surely recall. And then I grab the X and the Y. So, I'm sorry, axis 1 and axis 2. I grab all of axis 1 and axis 2, and then axis 0 is this. So you can see here, if I say give me a name, let's just do Python. You can see that I can then grab P, Y, T, H, O, and N. So I can use those positions in my array, that depth in my array, to get something to the screen. So what's the value here? Well, obviously this is a little bit impractical, but I could have loaded pretty much anything into my depth of my array. Perhaps if I had, maybe I was trying to pull in movie frames, frame by frame, I could actually have each frame in the movie be a slice of my array. So I can have X and Y. It's a two-dimensional image, right? I could have X and Y that way. I could do better than just ASCII art. I could have each item in the array at each depth could be RGB. It could be RGB coordinates, or to figure out the color of that pixel. The sky's the limit here. And I could have just created something where I grabbed each image. The first time I did this, I was trying to grab like level 1 of Super Mario Brothers, the original one where they play. You always see in the demonstrations, try to grab each frame of that and load it into the array, and it just turned into being too much of a thing. So I gave up on it to do this. But you can see how you could do something like that. You load each frame into the array, and then you could step through the array, printing it to the screen, and it would actually be like a video that way. I mean, that might be an interesting thing to do. Surely there's a lot that can be done here. It's just this example seemed to fit well with what I was trying to show you guys as far as some stuff you can do with three-dimensional. So that's everything I wanted to show you for NumPy. We're going to move now into Pandas. So NumPy is very numerical based. It's very much a traditional array where you have to have a data type and you do a lot of mathematical stuff to it. Pandas is more like multi-dimensional lists on steroids. You can load a lot of data into Pandas data frames. It's often the tool of choice for bringing in data sets into Python when you've got varied data types, because you're not, unlike NumPy, you don't have to have a specific data type, and then the add-ons to this are just crazy. There's tons of things you can do here, but we're going to start learning about it. So I stole this definition because it just sounded fancy. Pandas data frames are two-dimensional, size-mutable, potentially heterogeneous tabular data structures with labeled axes, rows and columns. So a data frame is only two-dimensional. There's also something called a Pandas series, which we'll look at briefly, which is essentially a one-dimensional Pandas data frame. They do not do three-dimensional Pandas data frames, although you could probably manipulate them into doing it. It's not what it is structured for. So we're going to just work with a simple data set here just to see some of the things we can do in data frames. So first of all, it's another import. You got to import Pandas. Just like with NumPy, you always see import NumPy as NP. Everybody really that I see do this does import Pandas as PD. So that whenever you're looking at code online, that should be very recognizable, and you probably should just follow the same standard. And I'll go ahead and do that. So we're going to import a file. We're going to define the separator for that file, and we're going to assign an index column, because if you know databases, or even like if you're working in Microsoft Access, if you create a table and you don't assign a primary key or an index, it will automatically get assigned. Pandas does the same thing. If you don't say, hey, this is my unique identifier for this data set, it will just increment at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's always going to be a primary index or a primary key for it. And if you have one in your data, you want to make sure your data gets assigned that way. So this is called user data. It's the variable I'm creating. And I'm going to do pd.readcsv, which is just a way to pull data into your program. Nothing super weird here. File name, I've got it in the same directory as my program, so I don't have to do any searching for it or backslashes or any of that. I'm assigning the separator. This data set I'm using is a bar separated. Let me just show you what it looks like. Here we go. So you can see it's bar separated. So that is what I tell it it's separated, otherwise it won't know how to split it out into columns. And then I want to assign an index column of user ID. So again, if I look over here, you can see the user ID in the data, increments 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would be kind of dumb if I didn't force it to use that as the index column, because then I would just get another column right next to it that says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that wouldn't be very useful and could easily cause confusion. So I'm assigning the index column that way. And now I have pulled my data into my program, and it's in this this variable here. If I wanted to, I could print type user. I don't know if I did this. I probably do on the very next slide here, but print the type, and you can see I've got a Pandas data frame as my class. So continuing on, let's have a look at some of the rows in that data that we've just imported. A lot of times when you put things into a Pandas data frame, ends up being like a large thing, like you're bringing in 50,000 rows of data times 20 columns or something, and it can get really hard to see it on just a single screen like this. So one way to help with that, when you're just trying to observe the data, just to have a quick look, is just to grab a few of the rows and print it. This is a common way to do that. I am printing the data frame .head, which means give me the top X number of rows to print to the screen. So it defaults to 5. So if I didn't put anything inside that parentheses, it would just give me the first 5 rows. But I just explicitly defined it here just so you can see it. So user data.head 5 will return your header or your column label, and then however many rows you asked it to return. So I can very quickly just see, okay, this is about what I expected it to be when I loaded it in. I can see some of the information. But if I don't put the head here, if I just do this, then I get a view like this where it's compressed. So I get the first 5 rows, I get the last 5 rows, and then I get dots indicating there's X number of rows in between. So just so you're aware of that. I have more than 10 rows in my data set, obviously. I have 943, as you can see here, 943 rows by 4 columns. Okay? The same as head, you might want to print tail, which just means it gives you the certain number of items at the end of the list. You can't see it on my screen here, but it essentially gives me those last 7 rows in this case. We can observe a few other things about this, actually a lot of things, but here's a few other ones we want to observe. I can look at the data types. As I said, it doesn't need to be a single data type, it can be multiples. So if I run this, it tells me for each column in the data frame what the data type is. And it automatically assigns a data type when you bring it in. You can explicitly assign it, but it will assign it for you. So you can see age, it has determined as an integer, and then gender, object, and zip code were basically non-numeric. So it gives them an object type. And then overall data type is object for the frame. Here's a couple other things. I can print the user data shape on index 0, and then, or on axis 0 and on axis 1. So if I do that, you can see, just like with NumPy, because Pandas is built off of the NumPy stuff, it's an extension of it. Axis 0 would be my vertical axis. Axis 1 would be my horizontal axis. So I get 943 rows, I get 4 columns. And then I can just print out the columns if I want to, just to see age, gender, occupation, zip code, and then the overall data type for the frame. I can print out the index. You can see we assigned the index, so we know what it is. It's just 1, 2, 3, 4, 5, 6, whatever, up until 943, and then it's telling me the data type for the index, and the label for the index, which is user ID, and then the length. So it's just giving you all kinds of information, a lot of times more than you need when you're looking for specific pieces of data about your data set. I can also look at information about specific columns. I don't have to just look at everything. If I'm interested in a certain column, I can specify that. So here you can see I just want to see the top 10 rows, because I'm doing head 10, of occupation. And this actually does the same thing. These are just 2 ways to do this, the syntax. It can be either way. So I can either do it with as if it was a method or as if it's an index. So you can see I did 5 rows on the second one, but they're the same thing. So if I change this to 5, I get identical results. Just 2 different ways to say the same thing. But it gives me specific information about that column that I'm asking for. Continuing with that same column, I can say, hey, for that column in the data set, or in the frame, give me the value counts. And then I can even get a little bit meta here. I can say for that, so this will give you the counts of each individual value. So, if the word the was repeated 5 times, it would say the 5 times. I can actually do the count of those value counts to see how many different values are available. So I can do a count of the counts, and that seems a little weird, but it works really well. And then on this last one here, so first you can see I've got counts of all of the different words, and then the second one I've got that there are 21 different values in the data set, and then the NUnique runs off my screen. So let me bring it up here. This is the same thing. This one and this one are the same. It's, again, two different ways to say it. I think I like this one better because it's more explicit. I read it well this way. Not everybody does. They sometimes prefer this one, where I can just quickly see what are the count of unique values in that column. All right, continuing. I can print the top 5 value counts of my data set. So I can just grab the most common values. That can be valuable. If you're trying to grab, I believe I need you to do that in the assignment, something of that nature. So grabbing just the most common ones, this is a way to do that. And you can also use describe, which is a very common thing you want to do when you're first observing a data set. You don't know a lot about it. Describe just gives you some quick information about it. You can kind of see the statistical data around the numerical columns. You see, even though I didn't specify a column, the only one that it gave me the data back was on the age column, because it's the only one that the data frame considered numerical. It considered everything else to be kind of a text field. So it just gives me the information on that particular column. So this is count 943, no shock there, the mean, the standard deviation, the minimum value, what is the lowest 25%, what's the lowest 50%, which is essentially the mean, pretty similar to the mean, or you could call it the median, and then whatever is within 3/4 of the minimum, and then, of course, the maximum value. So it just gives you an idea of what the data set is shaped like. You could look at normalization here, sort of just kind of see an overall view of, is this kind of normalized data, or is it kind of off-skewed in some way? But even though it only showed me the number of columns, I can still force it to give me whatever information it can about all the columns. The difference here is that things like mean, standard deviation, these things don't apply to the non-numerical fields. And so whenever it does something like that where it can't handle it, you get this NaN. So it's just not a number, is what that is. And you're going to see that in different places when you're working with stuff. If it's like unknown or not a number or can't put anything in here, the data frame will automatically get NaNs for those values. But it can still be useful because I can see the counts, I can see how many unique options there are, whatever the top most common option is, and then the frequency of that value. So I mean, like there's still value there. It's just you get some of these ones where it's like I can't handle that because I don't know what you're asking. So it puts the not a none. Okay, it's also easy to look at something simple like the mean value for a column. So just very quickly, I can say, hey, on my data, on the age column, give me the average, and then give it to me in 3 decimal places. So very quickly, I can grab that piece of information. And that's the very simple stuff. Then we're going to do a little bit more here on this next topic. So it's just kind of split here in Blackboard. So I just threw the next topic. You get to have a short intro into Pandas series, which I alluded to earlier, as well as how you would merge 2 data frames, which is a very common thing to do. So I want to enrich our original data set with some zip code data, because that will allow me to get a more valuable set of data. So if we look at that same data from before, you can see the last column is a zip code column. Well, just by having a zip code, I can pull some information from the public domain about that zip code. So there's a ton I can pull from it, but simple things I can pull is primary, city, county, and state. And then I can pull that into my data set, because perhaps having that data explicitly in my data, that information in my data might be more helpful than just having the zip code. So I'm going to do that. But first, let's have a look at, or actually I'm going to do that right away. So I've got all zips. This is the zip data I'm going to pull in, and here's the data set if you want to see it. Again, this is another one that's available in Blackboard for you. It's got the zip code, the primary city, the state, and the county. And I just want to add those to my data set because I want to utilize them. So I'm going to pull it in just like I did last time. This time I have a separator of comma, and I'm going to have the zip code be my index column because I know it's a unique value in my data set. And then I'm just going to print out the head so you can see it, and then I'm going to print out the data type because that's going to be important in a minute. So you can see I've got my data came in just fine, and then it's taking city, state, and county and assigning them an object type. Yeah, so that's all the data that I wanted to show for that. If you look at the data type output, you can see that the data type for the zip code field is int64. This doesn't match the user data zip code field because it ended up with a type of object. So if I wanted to combine these two data frames on the zip code field, I currently couldn't, because Python or Pandas is considering one of them a text field and one of them a number field. So when you try to combine them, it's not going to find any matches because they're two different, even though they might say 1, 2, 3, 4, 5, one's a text and one's a number. So we can't do that. We got to make some adjustment here. So what I have to do is I have to force my user data zip code field to become numeric. This is all just the syntax you have to use for this. And I have to force errors to coerce, because what could happen, and what does happen with this data set, is there's a few of them that it just can't convert. Either they're blank or they're just not formatted right, and so it kicks out errors. But you can ignore the errors and just force it to do what you want it to do, and that's what I'm doing here. I'm saying just go ahead and apply everything that you can, and then throw not a num or NaN into anything that doesn't have an appropriate structure. Otherwise, you can't move on sometimes. And that's very common to run into this, where you've got, 20,000 rows and 3 of them have a problem, and you can spend your whole day trying to correct it to get it to load, or you can load it and then go look at what's wrong afterwards. Sometimes that's easier, or you can ignore those rows after the fact when they're misaligned or misstructured. So I'm going to bring it in, or I'm going to adjust it to be a text or a number field, and then I'm going to show the data types so you can see the change, and I'm going to there's no reason to grab the top 25, I'll just grab the top 5 rows. So now you can see that zip code is now a float 64, which is what I needed it to be. Float and int, you can combine float and int without any issues. And I just grabbed the top rows. You can see that zip code is obviously a float now because it's got the 0.0 on the end of it. So I'm going to do a describe. So you can see that I've got my data set there. It's showing some common information about it. So I'm ready to utilize my all zips information. Okay, now that we have unified form data types, or at least similar data types, we can do a SQL type join to combine our 2 frames. So it kind of works like SQL. If you haven't used it before, you can do left joins, you can do right joins, you can do inner joins, and you can do outer joins. What I want to do is I want to keep all of my data from my user data, and I want to enrich that data with my zip data. So on my left is my user data, on my right is my zip data, and I want to do a left join. So I will keep every row I have in my user data, and anywhere I find a match in my zip data, it will be enriched with my zip data. If I'd have done it the other way, I might lose some rows, which I don't want to do. I want to keep all of my user data. That's my main data set. So I want to keep that and then just add to it. So here's my new merged data frame. I will strongly recommend that you don't overwrite one of the data frames that you're doing with your merging. Create a new one so you still have your original data frames. If and when something goes wrong, you don't have to try to recreate them again. You just have a new data frame that's garbage, and then you just recreate it if it's no good. So I'm creating a new data frame called merged data frame, and it is going to merge user data. It's going to merge with user data, so user data.merge, and what I'm going to merge into it is all zips. The how is where I was talking about you could do left, right, inner, or outer. I'm doing a left join, and I'm joining on the zip code field. And then I'm going to just print out my merged data frame, and I'm going to print out the shape. And there you go. Now this is a view of my new merged data frame, and you can see I've got my information from my original data set, and then it's been merged with data from my zip code. So now my data is more valuable or more usable if for whatever reason I needed this information to do whatever analysis I'm doing. I've still got 943 rows, so that's good. Nothing has gone weird there. However, not all is well. And I'm going to show you. Here you can see I am going to print the number of unique states. And oddly enough, I get 53, which there's not 53 states in that data set. So something is wrong there. And then I also try to print, let me redo this, but hash this out. the value counts I was trying to show you. I guess that's the same thing. I don't know why I did that twice, but something's wrong here, and I'm going to show you. Unfortunately, not all is well, and it doesn't immediately stand out. We ended up with rows in our data that are non-conforming, so the merge didn't work in every case. How do we know? Well, we can see the bad rows by finding any row that has that NaN in it. So here's how I can look at bad values. So I just created a bad value variable. And then I'm doing merge df, and then tell me anything is NA on axis 1. So it's going to look across the rows. And any row where it finds an NA, it's going to assign that to my bad values frame. And then I'm going to print it out. And you can see I ended up with, let me get out of this view. I ended up with, oh, gotta go all the way, nope, not quite. Where am I? Here we go. I ended up with, I don't know, something like 50 rows or something that did not merge correctly because of problems. And there's a couple of reasons for this. One, you can see my original data set didn't have zip codes. So when it tried to merge, it couldn't merge. So those rows were never going to be able to be mergeable. I took a look at some of these other ones. I think what happened here is some zip codes, since this data set is probably older than I'm messing with, some of those zip codes either no longer exist or they don't any longer exist. So when I tried to grab them off of a fresh USPS zip code file that I pulled down, they didn't find a match. So they just aren't there, so they couldn't match. So you end up with stuff like this. And when you're working with data, it's never perfectly clean. So you have to determine how do you want to handle these rows that don't act like you expect them to. So you have to kind of figure out in each scenario what you want to do about it. Okay, so that's that. Now topic 4 is some statistics stuff. Just simple stuff you can do to look when you're looking at your data frames. We're going to do some more in-depth stuff next week. Like NumPy, there are a ton of ways we can do statistical analysis on our data frames, and here's some, and some more next week. I was repeating myself a little bit there. For this example, I'm going to look at a red wine data set. So this is the data set. It's called red wine quality, and this has just got a bunch of columns: quality, fixed, acidity, volatile, acidity, citric acid, blah, 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 blah. A whole bunch of different columns with information. The important columns that I'm looking at here are the quality score and, I don't know, maybe the alcohol content, because I want a high alcohol content wine of good quality. I don't really drink red wine, so let's not give me that much credit. So I'm going to pull that data in, and then I'm not putting any kind of parameters on it. When you do a read CSV, by default, it assumes that it's comma separated, so I didn't have to do anything special there. And then I'm just going to print the head. I didn't print it, so that was kind of dumb. Print line data.head. There you go. I have a lot of columns here, so this sometimes looks a little weird. It's just showing the first 5, but it takes multiple rows in my output to see it all. That's why it does that. So you can see there are like 15 columns or something. But I'm going to hide that now. And you can see that this data set has about 1,600 rows and 12 columns. If I want to, maybe there's a data set column that I don't want. I know in the assignment I'm asking you to get rid of a column, so there's a couple of ways to do it. I'm going to get rid of the chlorides column based on its index position. So I'm going to overwrite my original data frame, which again I don't suggest you do that typically because you might mess something up. But I'm going to do a .drop, which means delete essentially, column 5, which remember we're 0 index, so that's the 6th one, and I have to define that it's on axis 1 because otherwise it would try to get rid of the 6th row. I want to get rid of the 6th column, so I can delete it that way. And then when I do this again, you can see that I lose. Well, it's gone because I deleted it, the chlorides column. So that's dropping a column from the data set. I can look at specific slices of this and then create new data frames from it. I mean, we did something like that with NumPy, so nothing should be a surprise here. It's kind of nice I can do it with labels if I want to. So I'm doing give me everything in my wine data, so locate everything in my wine data, again, index 0 is rows. So when I just do 2 dots like that, or a colon, I'm saying give me every single row, and then index or axis 1 is next. I'm saying just give me these 3 columns. So I'm asking for every row, but just those 3 columns. I could have specified which rows if I wanted to, but in this case, I'm just saying give me those 3 columns. So I could have just said, wine data quality pH equals this. So I could have assigned this into a brand new data frame and then gone off and worked with that specific data if I wanted to. So that's how you can access or slice up your data frames. I can look at whatever standard stats I like. I mean, the common stuff's obviously here. Give me the mean alcohol content. Give me the standard deviation of wine quality. I mean, the numbers, right? So that's pretty easy to do. I can do mathematical stuff either on the whole frame or specific columns and rows. For this example and what I ask you to do in the assignment, I'm going to make the quality of the wine be 100 based instead of 10 based, because I like 100 better than 10, or maybe I'm normalizing to somebody else's wine quality data set and I need to have it all be 100 based, something like that. There's surely a reason to do stuff like this. So I'm going to multiply my wine data quality column times 10, and then I'm going to assign it back to my wine data quality. And so it basically, instead of having a quality from 1 to 10, I've got a quality from 10 to 100. Because I'm only interested in high quality wine, I want to just take the above average wine rows and create a new data frame to store this. I don't want anything to do with wine that some really smart wine person decided wasn't very good. So I'm going to get rid of everything below average and then keep everything above average to do my analysis. So I'm going to create a data series which shows which rows have higher than average quality. So I'm calling it my high quality wine bool, because it's going to be a true-false data series. And in that, I'm going to check to see whether each value in my wine quality frame, whether it's greater than the mean. So it's going to figure out the mean value of the quality column, and then I'm going to check each value in that column to see whether it's better than average. And if it is, this will assign true in the series. If not, it will assign false. And I'm going to print you the output so you can see it. So essentially, I just get this big 1,599 length data series that is either false or true for each row in my data frame. I can use that Boolean series to create a data frame where only the rows that are true get moved over into the new data frame. So I can do it like this. So I can say anywhere wine data has true in wine or in high quality wine Boolean, assign it into high quality wine. And then you would expect I should get about half as many rows. I get 855 rows in my new data frame. And all of them are going to be, in this case, at least 60. So everything 6 and up must have been above the average. So it included it in the new data frame. So there you go. Now I have only high quality wine to look at for my analysis. Okay, so topic 5, Pandas time series. It's used quite often for, the Pandas is often used for time series. We're not going to really have much chance to dig into this deeply, but I did put a few links into Blackboard if you want to learn more about it. It can be very powerful when you're doing anything, an analysis that involves date time. It's really good for that. We won't really be getting into it much in this class, but it's something you should be aware of. If you've got a data set that has a timestamp associated with it and you think it's important for your analysis, you would want to look at Pandas time series. Okay, that's everything that I have to share this time. Hopefully you can go off and mess around with Pandas. It does have a learning curve, maybe a little bit higher of a learning curve than NumPy did, but it can be super powerful. And anytime you're messing around with data, it's something that you're going to want to understand how to use.